Hello, welcome to the video. In this lesson, we're going to be looking at section 3.2, where we're going to take a look at complex numbers. So up to this point, we have exclusively looked at real numbers. All right, so anything that you can solve on your calculator is deemed as real numbers. So the breakdown for real numbers are things like whole numbers, integers, you got rational numbers, you got irrational numbers, stuff like that. On the other side of this, you have what is called an imaginary numbers. Imaginary numbers are anything that falls into basically if you have any type of square root of like a negative number. So like remember if we tried to take the square root of any negative number, you would get some kind of error code in your calculator. Well, imaginary numbers fall into, square root of negative numbers fall into that imaginary number category. They also have a denoted symbol. All right, it is called I. All right, I for imaginary. There is also a term that you have for imaginary numbers, and that is also complex numbers, where you have both real and imaginary terms together. So it's like it's denoted as like A plus BI. So that's part of the imaginary number subset. And what we are going to do and what we're going to be introducing ourselves in is we have several different ways or several different opportunities to be able to discover how to get imaginary numbers from these square root values. So what we have here is they're talking about the square root of a negative number property. So anytime you have a negative number in the inside of the square root, you can denote that as the letter I. So basically you can say that anytime you have the square root of a negative 1 inside a square root, that is going to equal I. So here, if you notice this example, you have, oh, the square root of a negative 3. Well, this is like saying the square root of negative 1 times it by 3. Well, square root of negative 1 is I, so I goes to the outside. Square root of 3 can't be simplified, so that's why in this particular instance, it is I times it by the square root of 3. Another thing to keep in mind is if you have an I squared, if you have an I squared anytime uh, throughout a problem, that automatically equals a negative 1. Reason for that is you're like, okay, well, what is I? Well, I is the square root of a negative 1. Well, if I took the square root of a negative 1 and I squared it, it would equal negative 1. That's where that comes from. So anytime you see a I squared in any equation or expression, you get to immediately change that to a negative 1 and then go about solving it from there. All right, so here they're asking us to find the square root of each number. All right, so every single one of these uh, values inside the square root has a negative number. So uh, basically what you're going to do is you're just going to break them up into, all right, so like this is like -1 times it by 25. Well, the square root of 25 is 5, but you have the -1, which makes it 5i. All right. Square root of 72. So actually what you're going to do is you're going to break this up. You got -1 times it by, this is going to be, if you break this up in a, get an exact answer, this is like -1 times 8 times 9. Actually, no, I think I can get a better perfect number. Yes, I can. 36. So let's say if I went like this. So let's say I go -1 times 36 times 2. That's a better one. So square root of 36 is 6. Square root of -1 is I. And then what I'm left is with the square root of 2. Over here with C, this is going to be -5 on the outside. This is going to be the square root of -1 times it by 9. All right, square root of 9 is 3. 3 times -5 is -15. Square root of -1 is I, so this is -15i. All right, here it says they want us to find the value of x and y that satisfies the equation 2x minus 7i is equal to 10 plus yi. So how you're going to go about solving this one is this. What you're going to do is you're going to put all of your real value parts equal to each other. So in this particular instance, 2x is a real number and 10 is a real number. So you are going to separate those two things and say, oh, this is 2x is equal to 10. With that same idea, now I'm going to take my two imaginary terms because they have both I in there, and then I'm going to set those equal to each other. So this is going to be 7, -7i is equal to positive yi. So to get your values of x and y that satisfies the equation, you're just going to solve for each individual x and y. So I divide 2 here. X is equal to 5. Looks like I'm going to divide I to both sides. So now y is equal to -7. Here, they're talking about, it says finding the sum and difference of complex numbers. What you are going to do, you're basically, you're treating these like you're adding and subtracting polynomials. You're going to treat I just like a variable. So anytime there is, an I, you can combine like terms. In that instance, anytime you would multiply it, you would square it like you would any other variable. So keep that in mind when you are like either adding, subtracting, or even multiplying complex numbers. So here we're asking you to add or subtract. They want you to rewrite it in standard form. Standard form is that a plus bi form, where your real number value is in front, your imaginary value is written second. So just like you would to add polynomials, you're going to get them out of the parentheses. So this is just going to be 8 minus I. Because it's plus, you're going to leave the signs of the second term the same. So this is going to be plus 5 plus 4I. Like terms are 8 and 5 for my real number values. So this is going to be 13. And then negative I and 4I, that's going to be plus 3I. So 13 plus 3I is my answer in standard form. When it comes to subtracting, again, remember you get them out of the parentheses, you write the first set of parentheses how it is. If it was positive, it's positive. If it was negative, leave it negative. But because I have this subtraction here now, the second set of parentheses is now going to be represented as the opposite. So now this is going to be a negative 3. This is going to be a plus 6I. Then you go about combining like terms as followed. This now becomes, 4? And then this is going to be, since 6I and negative 6I are opposite coefficients of each other, those actually just cancel. So I'm left with a value of 4. For part C, again, here's some subtraction. So this is now going to be 13, and this is going to be minus 2 minus 7I plus 5I, because it's on the outside. All right, so my real number values are 13 and negative 2, which give me 11. And then I have negative 7I and positive 5I, which gives me negative 2I. Now again, multiplying, you're doing the same thing. And I would just advise that anytime you see I squared, immediately write it as negative 1. So here, multiply 4I by negative 6 and I, so now this turns into 4. Oh, I'm sorry. This turns into negative 24I, and then this is going to be plus 4I squared. But remember, I squared equals negative 1, so now this turns into negative 24I plus 4 times it by negative 1. So to rewrite this in standard form, this is going to be negative 4 minus 24I. Looking at B, what we have is essentially two binomials, so you're going to FOIL it. So 9 times negative 4 is negative 36. 9 times 7I is plus 63I. Negative 2I minus times by negative 4, so that's positive 8I. And then finally over here, I get a negative 14I squared. All right, now, if I combine these two terms here, I get negative, so I get negative 36 plus 71I. And then this is going to be minus 14, but I have a I squared, so this turns to negative 1. So this now becomes negative 36 plus 71I plus 14. I get to combine negative 36 and 14, so now that turns into, in standard form, negative 22 plus 71I. All right, so now here they're asking us to solve the equation. All right, for A, we have to isolate essentially the x squared. So this is going to be x squared is equal to negative 4. I get to take the square root here. Now the square root of x squared is x, but now we have the ability to answer a complex number equation, because now the square root of a negative number is now going to be plus or minus 2i. if we look at B, I'm going to add, what, 11. So what, negative 47 plus 11 is, so now I got 2x squared is equal to negative 36. Divide that by 2, so I get x squared is equal to negative 18. Take the square root of both sides here, so square root of x squared is x. This here, you're going to rewrite this as like negative 1 times it by 9 times it by 2. So x is going to be equal to plus or minus, it's still going to be plus or minus over here. It's going to be what? 3i times by the square root of 2. All right. Remember, when you put in the square root, you have to put in the plus or minus in for those values. And then finally here, again, they want you to find the zero, just like what we did in the previous lesson. That means we are setting the function or y, and we're taking that and setting it equal to 0. So this is just 4x squared plus 20, subtracting 20 from both sides. So now I got negative 20 is equal to 4x squared. Divide everything by 4. So now I get negative 5 is equal to x squared. Take the square root of both sides. So this is going to be plus or minus I times it by the square root of 5 is equal to x. And that is being able to look at complex numbers. Hope this helps. Till next time.